In this tutorial video, we'll look at how to set up a PoolKit pool. Let's start by creating a new local pool now by going to the Game Object menu and selecting PoolKit, Create Local Pool. You'll see that a new local pool has been created in the hierarchy and is already selected. A pool is essentially a manager for a bunch of prefabs. We'll be able to set up how many instances or clones of each prefab we want to create, and the pool will take care of the rest. We will be able to spawn these instances instead of instantiating them each time. The first thing we need to do is set up the core settings of the pool. One of PoolKit's unique features is being able to choose what kind of internal data set we want to use. This is known as the pool type. We can choose between using a dynamic list, a fixed array, or an automatic selection. A dynamic list can have its pool size grow dynamically over time and use features like lazy preloading. On the other hand, a fixed array is faster, but can't change its pool size. If you know how many instances you're going to need, and adding new instances isn't really critical, always go for the fixed array. Alternatively, you can choose automatic to have PoolKit decide what dataset to use for you, based on your choices. The next feature is pool protection. This will add extra checks to make sure you haven't accidentally deleted any instances and can rebuild your pool on the fly. More experienced users can choose to turn off pool protection in exchange for a performance boost. You can now choose whether to make your pool local or global with the Don't Destroy on Load option. Local pools are the easiest to work with. They are local because they only exist in the current scene. In other words, when we change levels, it will be destroyed. You can then control which pools you want to make available yourself on a scene-by-scene basis. Global pools are designed to be persistent across many or even all levels. Towards the end of the video, we'll show you the easiest way to make this pool a global one. For now, we'll stick with keeping it local to this scene. Finally, if we want to receive events from the API every time an instance in this pool is spawned or despawned, we can check the Enable Delegates and Events checkbox here. Let's add our first prefab to the pool by clicking into the Prefabs tab. There are currently no prefabs in the pool, but we can press the green plus button here to create a new prefab slot. I'll be using a prefab of a blue cube that I already have in my project. To add it to the pool, I simply drag and drop it into the prefab field in the inspector. Now that this slot has a prefab, we can start setting up how we want the pool to manage it. The core setting for every pool is how big it should be, and that can be found under pool size options. We can choose between keeping a pool size fixed, to have a pool expand within limits, or to always expand the pool when needed. A fixed pool size uses a fixed number of instances. In this case, 10 instances of the prefab will be created. Choosing expand pool within limits will grow the pool but keep it within a maximum limit. With the current settings, 10 instances will be created, but it will never grow to be more than 100. If we choose always expand pool when needed, no limits will be set and the pool can grow indefinitely. With the current settings, 10 instances will be created at start. Let's keep things simple for now and choose keep pool size fixed. Now that we've set up the pool size for this prefab, we can configure how its instances will be handled. We can do this by clicking into the Instances tab. The Instances section allows us to set up options for how instances will be scaled, how layers will be applied, whether we should keep instances organized, and whether we should recycle spawned instances. We can change the scale of these instances with the following options. Ignore will not change the scale. Prefab scale will set the scale to the settings of the prefab. Pool scale will set the size of the instance to the current scale of the pool. Custom scale will allow us to set a custom scale ourselves. The random range custom scale option will allow us to randomly scale the instance between two vector 3s. And finally, the random range proportional scale option is similar to the previous random range, but will keep the scalar uniform size. Most of these options will allow you to reapply the settings every time an instance is spawned. For now, we'll ignore scaling. If you want PoolKit to set your prefabs to a new layer, you have the following options. Ignore will not change the layer. Prefab layer will set the layer of the instance using the same setting as the prefab. The pool layer option will set the layer of the instance to the same setting as the pool. The custom layer option allows you to choose a layer from a drop-down list. Just like scaling, most options will allow you to reapply these settings every time an instance is spawned. For now, we'll ignore layer settings too. Keep instances organized is a feature that automatically moves your instances back to the pool when they are despawned. This keeps things tidier in the editor, but its main purpose is to help with global pools. If you change the parent of an instance and try to change scenes, this could break the pool. Pool protection can fix this on the fly, but it's recommended to keep global pools organized at all times, and you should make sure not to manually reparent instances that belong to global pools. As we're currently using a local pool, we can safely turn this off. There is actually a small performance boost when the pool doesn't have to reparent instances when they're despawned. So as a general rule of thumb, you should turn on this feature for global pools and turn it off for local ones. Another great feature is the ability to recycle spawned instances. If you run out of instances, you can choose to despawn and reuse existing instances instantly. This allows you to simulate having an infinite number of instances, but keeping the number controlled. Using this may have a very slight impact on performance, but should be unnoticeable in most cases. It works especially well with fixed array pool types. We'll test out this feature later in the video, but for now we'll leave it turned off. Now that we've explored the instances options, let's move on to the features tab. The features tab allows us to turn on extra features such as lazy preloading, which can gradually create instances over time, and the very handy automatic despawning feature, which allows us to easily set up despawning for basic instances right here at the pool level. Lazy preloading only works with lists, as it has to grow the pool. It's also worth noting that even though lazy preloading is heavily optimized, every time a new instance is added to the pool, that counts as an instantiation, so there will be unavoidable garbage collection that frame. Fixed array types avoid this completely, so choose if you need this feature wisely. Lazy preloading is best suited for select situations such as loading screens or at startup when you want a global pool to be created as quickly as possible and you don't mind having the entire list of instances loaded in slowly. If you want to enable lazy preloading, you can do so by checking this box. By default, at least one instance needs to be created with the pool, but you can increase this if desired. Before lazy preloading starts to instantiate new instances for the pool, you can set an initial delay. After the delay, you can tell the pool how many new instances you'd like to be instantiated on every pass. Finally, you can set the delay between each pass. You'll notice the yellow box below gives an overview of how your settings will work at runtime. These optional help boxes are scattered throughout the editors and helps you to learn how things work in PoolKit. For now, we'll turn off lazy preloading as we don't need it in a local pool. Automatic despawning is a great feature in PoolKit that allows you to despawn basic instances automatically at the pool's prefab level. If you have a simple particle effect, audio source or other object that will work in a predictable way each time, that would be a great match for automatic despawning. You can choose from various countdowns, as well as waiting for an audio source or particle system to finish. For the moment, we'll disable this feature, but we'll revisit it later. Now that we've taken a look at the features section, let's move on to the advanced tab. This tab is primarily focused on using your own custom scripts with PoolKit. Firstly, we can set up custom notifications to be sent to scripts on your prefab that have on-spawn and on-despawn methods. There are a variety of ways this can be achieved. The recommended and blazingly fast way is to use PoolKit listeners, which is an interface that can easily be added to your scripts that uses a unique PoolKit caching technique. You can also use send message and broadcast message options, but they are very slow in comparison, especially when sending a large number of events each frame. When you select these options in PoolKit, the optional helper boxes will often show you code snippets to remind you how to work with it. We'll cover setting up notifications in another video focused on scripting with the API. You can also choose to completely override the way PoolKit internally instantiates and destroys instances. This is a feature most users will never need, but is covered in more detail in the PoolKit documentation. We've finally covered every option in the Prefabs tab. If we click into the Statistics tab, you'll notice that it is unavailable until we run the pool in the editor. We'll return to this shortly, but first, we need to make sure the pool is set up correctly for the API. For this, we need to give the pool a short but descriptive name. As this pool is managing the cube, we'll call this pool the Cubes pool. We're now ready to test out our pool. It's worth taking a quick look at the blue cube in our project. Other than a collider and a rigid body, we have a simple script that will reset the rigid body velocities every time it is spawned. This isn't strictly needed, but makes things appear much more realistic. So let's quickly test the pool by creating a spawner. The spawner will have its own video, so we'll use default settings for the most part. We can do that by right-clicking in the hierarchy and choosing PoolKit, Create Spawner. We'll jump to the Prefabs tab of the spawner, add a new slot, and drag and drop our blue cube into it. Finally, we'll reposition the spawner in its Z-axis so we can see it better in the game view. Let's press play in the editor and see what happens. Our spawner is now spawning the blue cubes. We can quickly jump over to the profiler to look for those pesky purple spikes which indicate garbage collection. Nope, we're looking good. But it seems like there are no new cubes being spawned. It looks like the pool has run out of instances and the spawner can't spawn anything else. Let's head back to the pool to see what's going on. If we first look at the pool size, we'll be reminded that this pool had a maximum size of 10 instances. If we click into the Statistics tab, we can check to see if all 10 have been spawned. As suspected, this big blue bar representing the number of blue cubes is telling us that all 10 out of 10 blue cube instances are already in the scene. We can also see them free falling in the scene view. Let's look at how we can fix this by jumping back to the pool. A great and easy way to fix this is by enabling the Recycle Spawned Instances feature. This will use the existing spawned objects in the scene to allow the spawner to keep spawning instances. Before we press play, let's head over to the Statistics tab so we can watch the progress of the pool as more instances are requested by the spawner. Let's see it in action. You can see the instances bar increase as the spawner requests new cubes to spawn. Eventually, when we get to the 10th instance, we'll hit the limit of the pool and the Recycle Spawned Instances feature should kick in. And here we have it. Even though the pool has used all of its instances, we are still providing the spawner with cubes by recycling the existing objects. We can see this happening in the scene view by looking at the cubes at this high angle. As the cubes fall to the bottom, they are being pulled by the pool and recycled. This is how you can use a fixed array to simulate large numbers of instances without growing the size of the pool or using any new memory allocations. Another way we could have handled this is by adding an automatic despawner countdown. Earlier in the video, we talked about global pools. Let's see how we can change this local cubes pool we already have in the scene to a global pool. We need to save the pool as a prefab to do this. First, let's make a folder we can store it in. I'll call it the pools folder. It's also a good idea to change the name of the pool object so that it's easier to recognize it. I'm going to change it to PoolKit Cubes Pool. We can now drag and drop it into the folder we just created to save it as a prefab. We can now delete the pool from the scene. This is because we can have PoolKit automatically create global pools for us when the game starts. To do this, we'll right click in the hierarchy and go to PoolKit, Set up Global Pools. This will automatically open the PoolKit Global Pools asset in the plugins folder. In the inspector, we can add a list of global pools we'd like PoolKit to create for us when the game starts. All we need to do is click the green plus arrow and drag and drop our pool prefab into the list. You'll notice the inspector is showing us a warning. The pool we just dragged into the scene is set up as a local pool and will be skipped. To fix this, the editor is telling us to make sure the Don't Destroy on Load option is set on the pool. So let's go ahead and do that. When dealing with global pools, it's also a good idea to keep them organized. So let's enable that too. If we go back to the global pool setup screen, we can see that there are no more warnings and everything is ready to go. When we press play, we can see that the spawner is working normally, just like if we had a local pool setup. If we open the Don't Destroy on Load group in the hierarchy, we'll see that PoolKit has set up our pool automatically. It's this easy to make any pool global. I hope you all have enjoyed learning how to set up pools in PoolKit. In the next video, we'll take a look at setting up spawners. Thanks for watching.